Hello there and welcome. My name is Caio Castro. I am editor in chief at TelcoForge, and it's my pleasure to be here with you. Thank you so much for joining 60 Forge. And while we are in this break, I have the great pleasure to talk to René Nuessgen. René is Senior Director R&D at National Instruments. And today we'll talk about a lot of 6G and test and measurement and how those worlds interact. So, and we have been talking about 6G for a while now. We are seeing development, we're seeing investment in 6G. So, my question is, why do you think 6G is important? And why is it important to talk about 6G now?
Yes. So to me, the banner headline of 6G is profitability. If I look at 5G, 5G did not return on investments that was needed. So 6G really has to be designed with return on investments built from the beginning. And to me, it's kind of two critical things we need to take care of. One is performance efficiency, and the other one is sustainability. And sustainability a bit deeper. So this is kind of 6G is much more around softwareization. For instance, decoupling hardware and software. Much more about optimizing the networks to eventually balance performance, energy efficiency, but also this environmental responsibility. And so that leads me to one paradigm for 6G. It's understanding how the network is performing and how to apply that automation based optimization based on the KPIs and the insights we receive from the network. So that is one. The other one is really is AI. I mean, AI is an accelerator through which we can reach that efficiency and sustainability goals more broadly in our wireless networks. And again, AI as a best software technology to optimize that software-based run in the future.
And NI is a test and measurement company. So, I wonder, what does 6G mean for this test and measurement industry?
That is a great question. So we believe that this softwareization aspect I was talking about before really leads to a fundamental change in test for 6G. So more holistically, we even think about this like a paradigm shift. So uh, this is like a different way of thinking how we test future 6G networks. So it's really about this constant evaluation of the performance of the networks, uh, making sure that we take the input from the network, pass it through intelligence, make decisions based on the intent, and then really drive the performance improvements to the network. And to me, really, if you ask me the bigger question, I mean, 6G, to me, this is really what 6G is all about. And so the way we test is really like a different way of thinking. So I mean, looking at how we test today, it seems it follows a bit a waterfall software development mentality. So we do define the conformance test um, for the standard we want to go through. We test all the hardware deployed to the field, do monitoring with some handheld devices, have the KPIs we want to monitor, but we are not doing that cyclically. And so it's very much about get the deployment out the door, make sure states performance, but you're not doing that iterative update approach. So really taking a step back and just if we look what's happening already today, and so look at what CI/CD has done as a part of as a test practice inside this Open RAN alliance, and if we start mapping this to 6G, then we talk about that seamless integration of this AI/ML based workflow, AI/ML based optimization. Really, that leads to the big question: what does it mean from a testing perspective? Like this dynamic testing throughout that life cycle of a deployment. So that is where there's the fundamental shift how we will approach tests for 6G.
That's great. And then you mentioned several challenges and several areas where we should look into when talking about 6G. What is NI doing to overcome those challenges?
Yes, I think there are two pieces where NI is very strong and can help. So one is we need to prototype a lot of new technologies for 6G, and here our SDR USRP platform is best suited for this, especially as this is a software-defined radio, and we talk about softwareization. So this softwareization and the software-defined radio really to enable that AI workflow. That is one. The second piece is really how the USRP nicely interfaces to the rest of the world, or to the outside world. So one important piece is, for instance, GPUs. So GPUs are really used today to enable prototyping, for instance, of AI at the edge. So we have a USRP B25 plus NVIDIA Jetson a demo where we show a AI at the edge machine learning implementation of a spectral monitoring application. The other piece where we focus on is open source software. So open source software community is critical to this, and we are really engaging with the Eurocom, or we use the open interface stack to basically build out parts of the Open Run infrastructure that can enable the XApps and RApps that would leverage machine learning to eventually optimize the network. And the third piece I would like to point out is really, I mean, you mentioned it. We are a test and measurement company. And so, of course, looking at our own portfolio and our capability to perform those distributed, synchronized measurements, and if we look at the huge variety of physical sensors we as an eye bring to the table, we can really help to prototype and test 6G networks in a much better way in the future. So, for example, we have that compact Rio platform. This is a data acquisition capability with an FPGA that really supports, for instance, power monitoring, prototyping, and testing. So as we speak, key researchers use that platform to prototype and test, for instance, a 6G cell switch off and on, or other researchers take that approach, look into new physical layer schemas, like to optimize, for instance, the power efficiency of a physical layer. So to me, the combination of our RF USRP platform plus our own various kinds of sensors and huge I/O capabilities, plus the openness of our platform, really provides that capability of a very complex and powerful distributed synchronization of data, which eventually enables our customers to dynamically test and monitor the network. So that is maybe one big piece. The other big piece, which I find really interesting on a personal level, is if I think about the SDR. So to me, like, SDR is really important to 6G than it has been to any previous GE, because like the many new technologies, and also when we look at the softwareization aspect that's ahead of us.
Hey, before we wrap it up, I was curious to learn more about the workflow. So, can you talk more about the workflow?
Yes, that is a good point. So I was talking about the workflow, about this iterative approach to optimize, monitor, and optimize the network. But I think we can really have to take this one step further. When we talk about that iterative approach, I think digital twins will become very important also in a wireless space in the future. So having this concept of a real life version of the network, and on the other hand, have a simulated or digital version of the network, uh, that there's this feedback mechanism between these two pieces, and this is where an eye has frankly been for a very long time. So we as an eye have a lot of history in aerospace and defense, as well as transportation in the hardware in the loop test approach, which is sort of what the predecessor is to this digital twin approach. So you might have heard this NI Siemens case study we talked through a couple of months back, around this electrical train, where NI, for instance, played a key role with this HIL technology in creating a modular digital twin, enabling that comprehensive testing through simulation or HIL methods before going into the field. So to me, like, we can really stop now, take our broader NI tools and capabilities and apply them into the wireless space, where we are now able to add these wireless monitoring and wireless RAN observation capabilities in the future. So if I had to summarize a bit, so to me, 6G again is very much a business-driven standard, and 6G has to be designed with return of on investments built from the beginning. It's about performance efficiency. It's about sustainability. 6G is a big deal about around softwareization and this significant shift, a paradigm shift in testing, iterative approach, monitor and optimize the networks, seamless integration of AI/ML-based workflows, and then from an ICE perspective, key elements to making this 6G a success is again our software-centric approach to test, huge variety of I/O, our openness of the platform, and of course, a tight integration into this NI software ecosystem.
Hannah, that's fantastic. Thank you so much for being here. Thank you so much for making the time. And we look forward to talking to you soon.
Thank you very much, Kayo, and talk to you soon again. Thank you.